Welcome to Approach to ABGs Part 9. Is this compensation? We're going to go through some numerical examples of blood gases to determine if compensation is present or not. A reminder, the basic rules of compensation. The process of compensation must be the opposite of the process of the primary abnormality. So respiratory compensates metabolic, metabolic compensates respiratory. Obviously, the acid-base direction of the compensation is always the opposite of the primary abnormality. You have to look at the pH to determine what the primary abnormality or process is. Compensation usually undercorrects and never overcorrects. And if you have a normal pH, so 7.40, or it could be really close, 7.41, 7.39. If you have a normal pH, then you have two opposing processes and they are both primary processes. We would not label one of them primary and the other one compensatory. Memorize these rules. They are critical for your ABG interpretation. All right, example number 1. We've got a pH of 7.22, a PCO2 of 60, and a bicarb of 24. And we're going to ask the question, is compensation present or not? And reminder, we're going to analyze the osis first, and we're going to analyze the pH second to determine which process is the primary process. So CO2 is elevated at 60. This is going to shift the equation to the left. It's going to increase hydrogen ion concentration. The bicarb is completely normal, so it's not going to have any impact on shifting left or right. And there is no compensation in this blood gas because the bicarb is normal. In order to have compensation, we would need an opposing metabolic alkalosis process to balance off the respiratory acidosis process, but we don't have that. So in this example, there is no compensation. Here we have another example, pH 7.10, CO2 of 60, bicarb of 18. CO2 is elevated, shift left, increase the hydrogen ion concentration, bicarb is down, also shift left, also increase hydrogen ion concentration. In this example, there is no compensation because both the metabolic and respiratory osis processes are acidosis. So they're not the opposite, they're both driving the acidemia. Here's another example, 732, PCO2 of 60, bicarb of 30. Maybe seeing a pattern here, PCO2 of 60, shift left, hydrogen ions go up, bicarb is increased. This is going to shift to the right. This will reduce hydrogen ion concentration. And this is an example of compensation. We have to look at the pH to see which of these processes is primary and which one is compensatory. So the pH is less than 7.35, so we have acidemia. This means that the acidosis process, which is the respiratory process, is the primary. So we have a primary respiratory acidosis with acidemia, and the compensation is the metabolic alkalosis process. Next example, pH 7.40, PCO2 of 60, bicarb 36. PCO2 is elevated, shift left, hydrogen ions go up, bicarb is increased. This is going to shift right, drop the hydrogen ion concentration, and the question is, do we have compensation? And the answer is no. In this example, the pH is normal. And when this happens, we can't tell which process was primary and which one was secondary because they're both equal. Therefore, both processes are labeled primary. So we have a primary respiratory acidosis and a primary metabolic alkalosis. This is also called a mixed disorder. So we don't label either of these processes as compensatory. Next example, pH 7.47, CO2 of 60, bicarb of 42, CO2 is up, shift left, increase your hydrogen, bicarb is up, shift right, drop your hydrogen, look at the pH, it's greater than 7.47, so now we have alkalemia. Therefore, we have a primary metabolic alkalosis with alkalemia, and we do have compensation, but this time the respiratory process is compensatory. So in this example, the metabolic process is bigger than the respiratory process, and we know this because the pH is alkalemia. It's greater than 7.45. So let's re-examine the last 5 cases, and you probably figured out by now, in each case, the PCO2 was 60 every time, but the compensation was different for every case. Let's review. In the first case, the bicarb was normal, so we had no compensation. We only had one process happening, which was respiratory acidosis. In the second case, the bicarb was also an acidosis process, so we had no compensation. In the third case, we did have compensation. The pH was acidemia. Therefore, the primary process was the respiratory acidosis. In the fourth example, the pH was normal, so we have 2 primary processes as opposed to 1 primary process and 1 compensatory process. And the last example, the pH was alkalemic, 747. So this made the metabolic process primary, and even though the PCO2 was really high at 60, the respiratory process became the compensatory process. So the opposite of example number 3, because the pH was in the alkalemia range. So in every case here, we had a PCO2 of 60, and we've demonstrated 5 different examples of compensation present or absent. And this is the reason why people get confused with compensation, because you always have to analyze in a very specific sequence, and you have to be very thoughtful about the decisions and conclusions that you're drawing. Reminder again, the basic rules of compensation: the process is always going to be the opposite. The compensation process is the opposite of the primary. The acid-base direction is always the opposite. You have to look at the pH to determine what the primary abnormality or process is, and we just demonstrated good examples of that. Compensation usually undercorrects and never overcorrects. And when you have a normal pH with 2 opposing processes, then you have 2 different primary processes. Again, memorize these rules. They are critical for ABG interpretation. It is not compensation if the PCO2 is normal, because that would mean there's no respiratory process. If the bicarb is normal, there's no compensation because the bicarb is not doing anything. And if the pH is very close to normal, 739, 740, 741. If any of these values are normal, you do not have compensation. So this is a little shortcut. You can just take a look. If any one of the three values in the blood gas is normal, you do not have compensation.